हेलो अस्सलाम वालेकुम।
वालेकुम अस्सलाम।
माशाल्लाह बहुत से लोग आ गए, कितने आ रहे हैं, 25 के करीब आ गए। और इसके बाद जो है हम शुरू करते हैं इंशाल्लाह। वक्त शुरू वक्त जाया नहीं करना। तो 44 मिनट्स हो गए, 4 मिनट ऊपर हो गए। सो लेट मी स्टार्ट। वॉल्यूम अगर आपको ज्यादा लग रहा है तो बहुत अच्छी बोल रहा है, बहुत लो वॉल्यूम रखने से मसला हो जाएगा, रिकॉर्डिंग में नहीं आएगा। तो आप अपने अपने सिस्टम का वॉल्यूम, अपने अपने लैपटॉप्स का वॉल्यूम वो कम कर दें अगर आपको ज्यादा नॉइजी लगे। तो कल ये शिकायत आई थी कि नॉइजी है, कुछ कहते थे सुनाई नहीं दे रहा। ये उस वक्त होता है जब आपके अपने सिस्टम का प्रॉब्लम होता है। Last time we were doing this overview, approach how to design HVAC system. Now, can you see my PDF document open?
Yes, sir.
Okay, so should I start? The reading, can you see the heading, typical design approach?
Okay.
So this is slide number 6. Yesterday we discussed that these are the approaches when we design. We first calculate load, then find out locate where are the diffusers to be located, then we mark out on the joints, architectural drawings, we mark out air distribution system, then we locate on that line where we should put air handling units, there will be the machine room and chilled water distribution system. Then we stop at slide number 7 and 8. So let me start 7 as well. So in this slide, page number 7 was air handling unit was discussed. There are two types of air handling unit design approaches, one well-cut system, number 2 multi-zone system. I hope you understood it. Now, yesterday I also uploaded my recording of the yesterday's review. So I hope you have a link. When you click the link, you will reach that place where I stored it in Google Drive. Have you done that? Anybody have done that? Can you hear me? Hello? Can you hear me? Anybody hear me? Anybody hear me? Answer me.
Yes, sir.
I told that कल मैंने अपने ईमेल में लिंक अपलोड किया वीडियो का, जो हमने रिकॉर्ड कर लिया, उसको क्लिक करने से आप गूगल ड्राइव में उसको ओपन कर उसको डाउनलोड कर सकें। गूगल ड्राइव में जाकर उसको डाउनलोड कर सकेंगे, डाउनलोड करके अपने सिस्टम पर देख सकते हैं वर्टिस लेवल का टाइम को। उनके लिए भी अच्छा है जिन्होंने लेक्चर अटेंड नहीं किया, उनके लिए अच्छा जिनको लेक्चर अटेंड किया या लेट किया या कुछ मिस कर दिया, तो वो आप अपना वीडियो देखकर यहाँ से मर्जी आप कंटिन्यू कर सकते हैं। So now allow me to mute you so I could continue my lecture. Now, we know air water system we use combination of conditioned air and zone water coils, ventilation. Ventilation is always required in central air conditioning system. Without ventilation, air is not good for health, and it is very, very dangerous, particularly all viral diseases and lung diseases start with improper ventilation. So zone heating and cooling loads can be met with fan pumps. So in some zones, some remote areas, some small corners where circulation of air is not enough, we provide fan units over there. This is that goes. Now, general system now we go to general system classification. So this general system classification, we will discuss secondary HVAC equipment. People still running. Secondary HVAC equipment and system generally, there are two types: secondary HVAC equipment, air distribution system, water distribution system, and now primary HVAC equipment includes soil slot heating and cooling. Soil slot cooling is, vapor compression, vapor absorption refrigeration machine. It was studied in the first part and before midterm. What are the types of refrigeration system? So vapor compression and vapor absorption system machines will provide source of cooling. In source of heating, you can use water heating boiler or water boiling water, steam boiler. So steam or hot water is circulated. As yesterday I told you, in central air handling room, there are cooling coils, heating coils, and humidifiers. For humidification and heating, we need steam and warm water. Now, there may be boilers, engines, and generators are also required. These electricity sources are not available. Then thermal storage system may also be required because huge air conditioning system based on chilled water system, or it may be electrically driven, it may be heat driven. So we need thermal storage because a large amount of, for example, large amount of cooling is done. That cooling as a chilled water can be stored for in the night. It works 24 hours a day. In the night, when building load is zero, you can, and in the daytime, building load is maximum. So in case you cannot meet, your system cannot meet full day load in summer, full summer, then what you can do in the night when there is no sunlight and there is no cooling load required, if there is no occupants in the building is not operating, but air conditioning system is working, you can store chilled water in large quantities in tanks, special tanks which are insulated, and in the daytime you can do it at the peak time. This is called thermal storage. Similarly, in winter zone, when electricity is available, sometimes load shedding is in different times of the day. And when there is a lot of electricity is available without load shedding, then you can use this electricity and store hot water. Our foods, if it is gas operated, sometimes gas pressure is down, so you can store large amount of hot water and steam in your system, and in the daytime in winter season, cold winter season, you can use it. Now, air delivery, how to deliver air in the zone, that is air delivery. So it may be mixed, this zone may be mixed type, and this, for example, supply air is mixed uniformly with room air, and air can be introduced at ceiling, walls, floor, access level, and with the help of diffuser. This diffuser system is called air distribution system. Now, displacement ventilation means you supply air slowly at the floor, and air rises above absorbing heat and pollutants, and from above eye level in the wall or ceiling, extract that grains. Now, energy efficient design should be energy efficient. This is part of our learning objectives, learning outcomes of this lecture, and that is energy efficiency of the design. Design from the day first should be done energy efficient. So this is when you design chilled water pipes, then you select chilled water pump. This is when you design air supply and distribution ducts, and when you select fans for air distribution systems. So selection of chiller, selection of fan coil units, design of the pipe size and pipe friction losses, and duct size and duct friction losses. These will be in detail discussed in relevant chapters which are coming ahead. So properly sized two-way valve system should be designed two-way wall. So what comes two-way wall? It helps to supply in one direction and stop in another direction. It may distribute measured quantity of flow of water or air in one direction and divert the remaining to the other direction. So in order to save energy. Now we cannot cooling and heating is not done free. It costs money. Because we've done we use electricity, and if there is increase, sometimes it is not sustainable. Owners cannot afford it, so they disconnect the service and they cause nuisance to the tenants and customers. So that's why we have to run the operating engineer's responsibility and designers. Designing engineer's responsibility to design in such a manner that it will consume less energy. Now, electric chillers are those which you have learned in the refrigeration part. Refrigeration, you can see this typical vapor compression system. So you have evaporator, condenser, compressor. This is compressor, this is evaporator, this is condenser, and this is throttling device. So this vapor compression system is driven by electricity because you supply electricity with the compressor overhead. Now we have expansion valve, we have evaporator, condenser, and compressors are of different size, different types. We discussed in the refrigeration part, so I must not in detail. We discussed this in the refrigeration part. So there are basically picking time, store time, screw tightens, and cable type. If you don't remember, you can open your my initial lectures of refrigeration part before midterm. Now, again, here some diagrams, some figures, photos are shown from manufacturers with cutter review. So all the metrics can be. You should make habit of getting images from Google of anything if you don't know how it looks like. So as an engineer, you should know beforehand before passing out from here, getting graduated. You will go for interview or you will go for some job. So these things should be familiar to you. So their shape should be from your size and shape estimate you should have in your mind by watching the photos. Now, evaporator is the device where refrigerant evaporates at very low temperature and low pressure and creates cooling. It takes a big load on the fluid space. Refrigerant to water heat exchangers, we have typical water in there are water in tubes and refrigerant in the shell. So it goes in the chiller. This is the chiller design. So refrigerant in the shell and tubes in the water. This is called shell and tube heat exchanger. So condenser evaporator is nothing to do with refrigeration system, but basically from heat transfer point of view, they are called heat exchangers. Heat transfer. In heat transfer, something we want to learn types of heat exchangers. Shell and tube pipe and water maybe one medium like water in chiller plug, maybe in tubes, and refrigerant maybe boiling in shell. Usually it is designed for constant water flow. Condenser may be water cooled, condenser may be air cooled. So air down image is shown very long shell with pipes inside. So this is water cooled and their upper side, their huge plant, about a dozen, more than a dozen fans on top, and from the side it sucks air, and from the top it exhausts air. So this is called air cool. So refrigerant, hot refrigerant gas after compression goes to this condenser, and from there it needs removal of heat, discharge of heat to air or water. So if it is air cooled, it's called air cooled. If it is water cooled, then it's called water. So because of this, we reject heat to the environment by refrigeration machine. Now, we discuss from energy point of view chiller performance. Chiller performance. Okay. So time is very little time is left, 10 minutes more. So we will continue. Large chillers are more efficient. Capacity and efficiency increased by compressor lift. Compressor lift, capacity and efficiency increases when compressor lift is reduced. You know, this is compressor lift is just like you walk upstairs. You walk upstairs. If you have to walk four-story building by foot without lift, so then you will have to exert energy. The same is for air conditioning machine. So chiller machine lift should be small. That means evaporator pressure difference between evaporator pressure and condenser pressure should be small. So condenser pressure you cannot regulate. You cannot regulate because it depends on environment. Now these days today Karachi is 43 degrees centigrade. So this you cannot regulate. This changing with time, with day, with season, and in one day different hours of the day. So environmental temperature and evaporation at big temperature, too much cooling will cause a lot of lift for the evaporator. So a lot of work will be done, a lot of energy consumption. So evaporation pressure should be kept as minimum as possible in order to make it energy efficient. Now, hot load performance. Sometimes, see, huge air conditioning plants are designed for maximum load during summertime. So if summertime is not started, but it is just started, our summertime is going down and fall season is coming. So then we don't need full capacity of that chiller. So you cannot buy under capacity chiller because in peak condition it will not cool. So that's why what we do is we buy chiller full capacity, full design capacity, but when it is when there is load is not there, for example, it's night time, or for example, building is partially occupied, then we need to reduce the running capacity of that chiller. But this causes energy loss. If you run 300 ton capacity chiller at 100 ton capacity, building load is 100 ton and you are running 300 ton chiller on that load, then that will consume more energy. This curve shows that part load means, for example, if it is running on somewhere 50 ton, but normal capacity is 400 ton. So 400 ton energy consumption will be minimum. So the unit of energy consumption is energy information, kilowatts per ton, hour per capacity. So how much electricity will be consumed in kilowatt per ton of cooling? So it depends on running a full capacity or part load. For full capacity, this unit will run at around, this consumes around half kilowatt per ton. But if capacity is not there, it is running on 50 ton capacity, building is not occupied, so it will consume as high as 3 kilowatt per ton of cooling. So this we should consider at the time of selection of chiller and at the time of running the chiller. Now, energy efficient HVAC design needs high efficiency components. Selection of high efficiency components designed for part load conditions and heuristic design criteria should be questioned. What is heuristic design criteria? Sometimes senior people, senior engineer experience in the boss, if they have the experience, you are the engineer, and this and that. So it should be done. I should select 400 ton chiller. So, but your calculation says and your knowledge says, scientific knowledge says that no, this will cause energy loss. So then you should trust your calculation and not heuristic design criteria. Heuristic means designed by practice, not by science. Now, high efficiency component chiller is the energy consuming component. Power fans are energy consuming components. Pumps, chilled water pumps are energy consuming components. Electric motors are fans and pumps. They are energy consuming components. So these should be considered from the very start of the design. It's a paperwork. You've not bought the equipment, you've not started, but you're designing it on the drawing, on the paper. So that case, if you design efficiently from the energy point of view, then at the long run, so this will be very, very cost effective. Design of part load conditions, you should guess based on your experience. So this chiller may work in part load condition also. But that very high capacity chiller should not be selected. If you need 400 ton chiller, better select 2 chillers of 200 ton capacity. So at full load, you can put on 2 chillers at a time. At half load, you can chiller only one chiller of 200 ton capacity. In that case, part load, every chiller, both of the chillers will work when time is needed. When it is needed, they will work at full load, and which will be most efficient. So, fortunately, we are lucky enough to finish this part of the lecture. So, with this, Zoom 3 lecture is completed, but I can share one more which will show the pictures. Where is that? Images. So, let me share this images. Some images are already seen. So this is what I do of the whole plant. So you can see this, and we have done it already. Typical small commercial equipment we have done already, and now I'll show you that part if you have not seen it. So package, we have seen it. So both of these images also when you have time, and this is the picture of fan coil unit, and this is the fan coil system of 4-pipe. There is 4-pipe system. Again, we will come to this topic later on when we design chilled water piping. There is one heating unit, one cooling unit, one boiler and one chiller. So in one season, in summer season, chiller will work and heater and his boiler will be closed. But this is inside the building. Inside the building, this is the location of fan coil unit in some zone, and it has outdoor air connection also, but these single line diagrams show chilled water coming to this fan coil. So it should have 2 coils, one for heating, one for cooling, and this is the fan which blows air vertically up in the building. So and at the top there is a exhaust fan, and the return air, there is a grill below, where this fan sucks return air from the building, and after passing to this coil, once in summer, it may be passing chilled water, connected to chilled water plant, and in winter it will be connected to heating plant. So hot water and steam will come in winter through this coil, and air will be heating, and in summer air will be cool. Now this is the concept of mixed style. This is the return. This is, you see, under the floor there are holes, grills, and duct lining under the floor. In Saudi Arabia, in Haramain Shurikan, in Maktoum Karna Masjid, and Masjid al-Nabi, this is the system. This is the system. Under the floor, supply air comes, and this outlet is given around the pillars of the building. There are a lot of pillars of the building, and every pillar of the building is supplying air from below duct pumps and exhaust upward, and all pilgrims get this cold air in summer. And exhaust is not done. return air does not go to the plant again. That is 100% out of air. And this prevents any type of infection. Where in the season, there you see around 2 million, 3 million people gathered there, and same air recirculation may cause epidemic. So that is why the return air should not go to the plant in such places where large number of people are gathering. This is for typical building. It may have all options are given here, but not all options are always used everywhere. You have to select one option. For example, it may have supply from baseboard in skirting. It may have supply from under the floor.